So in order for you to understand what Kafka is, I would highly recommend you to go and enroll to this course right here, where I teach you everything about microservices in terms of setting up everything from scratch, microservice communication, connecting to databases, logging, and a bunch more. So basically everything in here that we are doing. And previously we actually did connect to a RabbitMQ in here. So if you've missed that video as well, I would highly recommend you to go and check it out. Now, because we are learning about Kafka in here, we just have to replace this part right here, because Kafka can be also used as a message queue. So let's dive into Kafka to understand what it is. Kafka is a distributed streaming platform that allows producers to send events of streams right here to the broker, and then consumers can actually receive those events. And the way it works is through topics, and I'm going to explain topics in a second, but Kafka is a distributed streaming platform. Now, you might be wondering why distributed? Well, you can imagine that you want your application to be resilient, i.e. you don't want just one node to act as your Kafka broker. And instead, you can have 2, 3, 4, or thousands of nodes. So these are brokers that basically run your Kafka process. So these could be cross-region, different data centers, so on and so forth. And with Kafka, you can build real-time event-driven applications, such as, for example, location tracking. So maybe if you order food from Uber Eats, then when you see the driver updating his location on the app, that is done through Kafka. Kafka is fault tolerant, so you run a bunch of these nodes cross-region. It can scale, so if you basically need more brokers or if traffic increases, Kafka is highly scalable. And as I said, Kafka should always run as a cluster. Now, one difference here that you might be saying, okay, so what's the difference between Kafka and RabbitMQ, for example? Well, with Kafka, messages, when they are sent to the topic, they don't disappear. So they can stay there for a couple of minutes, couple of hours, couple of days, or even forever. Whereas in a traditional message queue, the messages are gone as soon as they are consumed. So we have producers and we have consumers on this side. Producers, these could be microservices or web application or anything really that wants to produce messages or events of streams. And then you have consumers. So again, this could be microservice to microservice communication, or maybe you want to send logs as well, or you want to build monitoring systems, including dashboards, or even do work with Hadoop. Also right here on the side, you can see that Kafka has something called Kafka Connect. So these are mainly for data integration. You've got Kafka Connect source. So this pulls data from your existing data sources into Kafka. And then you have Kafka Sync, which takes data of Kafka topics and then puts it into your data source. So the connect right here, so these are Java applications that run independently from the main process. There's also something called Kafka Streams. So this is a Java API, and it's mainly used for data processing and transformation. You can enrich data, you can transform data, you can perform filtering, grouping, aggregation, and a bunch more. Now here you can see that the arrows go both ways. So as data comes to Kafka, basically Streams performs all of these data processing, and then once you're done, you can actually put it back to a topic so that any other consumer that wants to consume that enriched data, they can do so. Now let's look where these events of streams are put inside of Kafka. So with Kafka, we have this concept of topic. And if you've seen my RabbitMQ, you've seen topics and different types of topics. But in Kafka, it's a little bit different. So a topic is a collection of events which is replicated and partitioned. So if you can imagine, so if you have messages going to your topic, then if you have a bunch of nodes, these are replicated and also partitioned. Now, partition here means that, so if you don't have a node which is big enough to hold this topic right here, the topic itself is actually partitioned across multiple nodes. As I said, it's durable, so you can store it for hours, days, years, or even forever. And there is nothing that says how big or small these topics can be. So there's no limit. So you have to decide what you want to store, and you can basically have really, really big topics or tiny topics. Now, in contrast to a message queue, such as RabbitMQ, as I've mentioned, a topic in here, you can think of it as a log. So if you've done any Java using log4j, storing logs to a log file, this is the exact same concept, right? So data going into the log can be kept for hours, days, years, or even forever. And once data is read off a topic, it's still there. It's still there. Whereas with a message queue, if, for example, this is read, then it's gone. But with Kafka, it's not the case, meaning that you can then have a bunch of other consumers reading off the same topic. So we have producers that stream data of records. So these are the records in here. And then we have consumers on the other side. So in our example, we are working with microservices. So we'll have a microservice that produces and then another one that consumes these records. Now, let me quickly touch on partitioning. So as I said, there is nothing that says whether a topic can be small or big. So there's no size limit for them really. Now, you could have one node that is big enough to hold one topic, right? So if you have a massive topic, you can have one giant node to hold that. Or instead, what you could do is, so these days, as you know, we can scale up or down because of the cloud and resources are cheap. And we can have a node which is kind of a medium size, right? So in this case here, let's say that from a giant node, we go to 3 or 4 small nodes. Now, because we have the topic, so we have a topic, this, because it doesn't fit on these smaller nodes, we have to partition it. So here we have partition 1, partition 2, so on and so forth. This is the main idea of Kafka. Next, let's go ahead and build a project with Kafka. So you see the integration, and we're going to create the broker, which will run locally. We'll also configure a topic, producer, and consumer, and then we'll have everything working together by sending and receiving events of streams.